I'm Anil Kumar. Now let us look into domain and range of rational functions. We have three examples for you. You need to write domain and range of y equals to minus 3 over x minus 2 plus 1. Four choices are given to you. You can pause the video, copy the question, answer, and then look into my suggestions. Here is the next question. Domain and range of the rational function 3x plus 1 divided by x squared plus 1. Again, four choices are given to you. Now, the next question here is y equals to x cubed over x squared minus 1. The last question in this series is domain and range of y equals to 2 over x squared plus 1. Again, four choices are given to you. Now, answer these and then look into the suggestions. Now, let's solve them one by one. To find domain and range of y equals to minus 3 over x minus 2 plus 1. Now, as you know, denominator cannot be 0, right? So, you can equate x minus 2 not equal to 0. That means x is not equal to 2. That is the domain. As far as y value is concerned, if this portion is not equal to 0, then y is not equal to 1. So, y is not equal to 1, correct? That is how you can get quick solution. You should know here that we have a vertical asymptote at x equals to 2 and we have a horizontal asymptote at y equals to 1, right? So, the function approaches these two values, but it is never at these values. So, we get our answer x is not equal to 2 and y is not equal to 1. That gives you option A as the correct option. The next one here is 3x plus 1, x squared plus 1 in the denominator. Now, if you try to make x squared plus 1 not equal to 0, we know this is never 0, right? This function will be always greater than equal to 1. Since x squared is positive, right? Greater than equal to 1, correct? So, there is no restriction on domain. So, x belongs to real numbers. Now, as far as the range is concerned, the function cannot be 0, right? Now, since degree of denominator is higher, than degree of numerator, what do we have? We have a horizontal asymptote, which is y equals to 0. So that is the horizontal asymptote, y equals to 0. Therefore, we do have a restriction, which is in the range y is not equal to 0. Right? So that is the right option. We are looking for x belonging to real number and y not equal to 0. That makes option B as the correct option, right? Next question here is cubic function divided by x squared minus 1, x cubed over x squared minus 1. Now, x squared minus 1 equals to 0 means x squared equals to 1. That means x equals to square root of 1. Whenever you do square root, you should write plus and minus, otherwise you'll get wrong answer. So that means x is not equal to plus minus 1, correct? Now, here degree of denominator is higher, right? No, lower, right? So degree of denominator is lower by 1, right? So by 1. So we have oblique asymptote. Well, you can always find that equation, but it also indicates in this particular case that there is no restriction on range. So in this case, we have no restriction on range. Okay, so y belongs to all real numbers and x is not equal to plus minus 1, which is option A. I would like you to graph and then answer. correct? Find the equation of oblique asymptote. We do have two vertical asymptotes, right? So we do have vertical asymptotes at x equals to plus minus 1. You can now find oblique asymptote and also the graph of this particular function. Let this be an additional exercise. Now we have the last question of this particular video. Now this is very interesting. It is better to graph this. So let's kind of sketch a graph. We know clearly that x squared plus 1 is always greater than equal to 1. So it is never 0, right? That means x belongs to real numbers. So domain has no restrictions. As far as the range is concerned, it could be maximum 2, right? Because we are dividing by something positive. So it's always positive. So it is kind of like this. If you divide by a very high number, you are going to get close to 0. And therefore, that is the kind of situation. And this is going to be 2 for x equals to 0, right? So what is the domain and range in this case? So the value can be 2, right? So y value has to be greater than 0 but less than equal to 2. X is all real numbers. Option B is the correct option, correct? So that is how you'll answer all these questions. Now let us look into domain and range of absolute function. You need to find domain and range of y equals to absolute value of minus x plus 2 minus 4. 4 options are given to you. Now here is the shortcut method. For absolute functions, we know domain is all real numbers, right? So domain is x belongs to real numbers. There are no restrictions. So we have to only concentrate on range, correct? That is the whole idea. Now in the given function, the function has been moved 4 units down and it is opening upwards. And therefore, here we can say y should be greater than or equal to minus 4. So we're looking for y greater than or equal to minus 4, domain being all real numbers. So option B is the right option. Perfect. Now let's look into another practice question based on absolute functions. You need to find domain and range of y equals to minus 1 minus absolute value. Now in this case, there are 4 options. You can pause the video, answer, and then look into my suggestions. Now take it as a test question. Okay, so what we are given here is this minus means reflection on x-axis. So if you be sketching a graph, your function has to go down, right, somewhere like this. This vertex will be at x equals to 2 and the y value is going to be 1, correct? So domain is not a problem. Domain is all real numbers, but the range is less than or equal to 1. So that is what you're looking for. Option B is the right option. So I hope this concept is clear, how you can easily find the solution for domain range of absolute functions. Now, after doing all this exercise with many functions, I have a test question for you. This time we have square root function. I would like you to copy this question and then answer. Let's look into the solution. Whenever you're given a function like this, it's a good idea to rewrite this. It is minus 3. That means it is reflected on the x-axis. Within square root, let's factor out minus 2. You get x plus 2, right? And here we have plus 1. Now, for a square root function, inside this square root, it should always be positive, non-negative 0, right? So basically, negative 2, x plus 2 should always be greater than or equal to 0. So if you divide by negative, the sign changes. So we get x plus 2 should be less than or equal to 0. Why did I change the sign? Because I multiplied by minus 2. That means x is less than or equals to minus 2. So that becomes the domain. Now as far as the range is concerned, we have 1 here and moving downwards, right? So it is downwards from 1. So it is y is less than equal to 1. So let's look into x, which is less than equal to minus 2, and y less than equal to 1. Option C is the right option. So that's an easy way of doing domain and range for any function. Look into the base and then apply the transformations. I hope that helps. Feel free to write your suggestions and your views. If you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.